Chen Ho, you better turn off the mic first. All right. So, good morning. I just see, right? Not all of you have turned on the camera. Okay, you have to turn on camera. I said last time.
Mr. Chin，我電腦係冇 camera，所以我而家用手機入翻。
Okay. Just wait for you, and I'd like to check the attendance first of all. Class number 1. Are you here? Number 1. Now double check some other attendance before we start. Class number 1, not here. Number 3. Number 17, 18, 19, 20, 21, 22, 23, 24, 6, 27. 27. Are you here? 33. Okay, I'll repeat number 1, number 3, 27, and 33. Are you here? Okay, I don't see that 3 students. Okay, for the others who have spot their presence, you have to let me know as well. Thank you. Now it seems that most of you have turned on the camera. If we could start. All right. So today we are continue on our topic. Last time I asked you guys to let me see. Yeah. To find to get to know more about the different materials, okay, in the world. So the best way is to check your understanding by take out the book as well as your worksheets. Okay, take it out now. Okay, this is the page, and you should have the book as well, because we need to counter check your understanding about those. And we would start from here. Yes, that's right. So let's say last time, can you see that? We've got the worksheets. All right. So as said before, we have got different materials in the world, and each one of them, when they are impure, they will have different uses. Okay, so let's take a look on the first one. Let's take a look on the first one. How about class number 1? Not here. Shall I ask? Yep, worksheets. This is the one. Can you see that? It's page 9 on your worksheets. No?
No.
Let me see. I have just shared this one. Can you see that? Now I switch it here. Can you see that?
Yes.
Yeah, finally you see it. Have you all seen that? This is the one. And class number 8. Class number 8. Tell me do you know what are the elements and which group that are they in? To make this, take a look. To make the mobile phone is actually that battery. Okay, the battery. So what is that?
Lithium.
Lithium. Yep. Which group does it belong to?
Group 1.
Yeah, group 1. Yes, that's right. Group 1. So with the formula Li. Okay, lithium. Group 1. Okay. So this is the one. Thank you. How about the second one? Add to fireworks to produce brilliant white sparks. So this is a very important characteristics, okay, of having such. Thank you. 16.
Yes.
Yep. Tell me what's that? Brilliant white spark.
Ông xin tội.
Symbol of this?
S T
strontium, you mean?
Yes.
Strontium. Now, strontium is also used in fireworks, but do you know the color? The color of strontium when I burn it on the in the fireworks. Do you know what is the color? You don't know?
I don't know.
Now, how would you get this? How would you get this on the web? You search it. Yes, somebody will write as red. That's right. Strontium is red, but this time is brilliant white sparks. So take a look on the maybe the diagram may be a little bit misleading to you. So you may find different color inside, but at this time we focus on white sparks. Okay, thank you. Thank you. Good try. And can I have 24?
Yes.
Yep. Tell me what is that? Acted in fireworks to produce brilliant white sparks.
Can you say again? I can't hear.
Page 9, the second one. The second one, the uses
Yes.
of different elements to make different color.
Yes. Sorry. It's very like.
Sorry.
Magnesium.
Magnesium, right? Very good.
Yes.
Magnesium. So the formula for this one is Mg. So it is in group what? Group what? Mr. Lee, could you please tell it again? So what is that?
Yes. Group 2.
Group 2. Okay, so indeed, you search it on the web. Have you ever searched it on the web to find out such information? Right, so you search, for example, you search on the web fireworks, color, ions. Okay, so we have got different combination. They will give you different color. So as said before, as the people, one of the students said it is strontium, but strontium is not. Can you see that? Strontium is red, barium is apple green, lithium is a little bit magenta, a pink color. Sodium, the color of it is the same as the street lamp. Do you know it? The street lamp will have got some orange or yellow color. We call it golden yellow. And copper is blue, while calcium is brick red. While you see for magnesium, I need what? I need some different color. So that different color, we may need to burn something. For example, I burn magnesium, I burn aluminium, I burn titanium, etc. But once we talk about some other color, you may see just like strontium, I do not burn the metal itself. I burn a compound. So what is compound? For example, strontium nitrate, strontium carbonate, strontium sulfate. So they are just, the metal part is just part of the compound. Okay, but instead of burning the metal directly, I can burn the salts and then I can produce the color. Okay, so this is what I would like to make a difference between them. So if you study chemistry, you know something more about that. Okay, so and you need to memorize some of the color. Okay, while you get promoted to Form 4. Okay, is that clear? Thank you. So take a look on that. Shall I invite some other students to help? Learn Parker in your time.
Aluminium.
Yep, aluminium group.
Group 3.
Yep, group 3. And group 3. So making soft drink cans. But indeed, if you want to, why not using iron? Why not using iron?
Iron will be corroded.
Yeah, iron will be corroded, especially when it meets something acidic. Okay, so you may find the soft drinks, most of them, they are acid. So the acid, they will corrode or the metal, aluminium, especially iron. Okay, give me some time because I found that this file is quite strange. Very often those wordings, they're just moving and you find it difficult to see, right? Do you still recognize the words is just fire? Floating, and I need to open them again. Sorry about that. I need to open another diagram and try to see if it is better. Now, yes, that's right. Let me see. Oh, okay. Why? Why so strange? Let me put it this way. What if I change it to PDF? It may be better. Sorry about that. You just wait for a while. And yeah, PDF now. Now we are out here. Now let me see if it is better. Now we come to here. Oops, too large. Aluminium. Yes, perfect. Now, thank you. How about making glass? How about making glass? 27. Carbon. Making glass. What can make glass? Silicon, okay, silicon. SiLicon with formula Si group. Which group does it belong to?
Group 6.
Group 6?
Group 4.
Group 4, number 14, okay? Atomic number 14 belonging to group 4, 2H4. So indeed, it is not just silicon. It is indeed what we call it as a compound. We call it silicates. Silicates. 硅酸鹽啊 okay? So it is indeed a type of a compound. Okay, part of the compound, mainly sodium, sodium silicate. Thank you. How about making matches? How about making matches?
Phosphorus.
Phosphorus, yes, that's right, phosphorus. So remember, be aware of the spelling of phosphorus. Okay, phosphorus, number 15, with the electronic arrangement 2H5, group 5. Okay, making matches. What I mean is for this part. Okay, once it have a friction. Okay, I touch it against that quickly. I touch it, rub it against quickly, and the fire will be produced. So I need phosphorus. How about this? Used to help patients with breathing difficulties. 彭樂賢
Oxygen.
Oxygen, okay, which group?
Group 6.
Group 6, okay, so atomic number is 8. Okay, we've got 2, 6. Okay, and oxygen is indeed, it's not that simple. It is indeed work in pairs. We call it O2. So very often we call it O2. It is a type of O2 molecules. So used to help patients with breathing difficulty. So remember, now once it is we will have this, they will not give you pure oxygen. The answer is no. Okay, they will not give you pure oxygen because pure oxygen is toxic. So that get mixed with air. So you may have that mass here. We've got some hole here, right? That hole, they will help take in the air inside. So get mixed of the two. Indeed, we have got a high concentration oxygen gas. So this is what you have to know. Thank you. So take a look. 何超華 killing germs in swimming pool and drinking water.
Chlorine.
Chlorine, yes, number
Yes.
17. Okay, chlorine, group 7, thank you. Killing germs in swimming pool and drinking water. This is the one. And it is not just chlorine, which can kill germs, but also bromine and iodine. Okay, also it can also kill germs. But it is the main use of this is to clean the wound. 洗傷口啊 is used to clean the wound because the effect is not so serious, so it's not so big. Okay, it's not so severe. So I need to use it to clean the wound. So bromine iodine, for example, iodine tincture, 丁明碘酒啊 is just one of them. Iodine tincture. So this is one of them, for example. So it will kill the germ. So because all three, they are toxic. It is also an oxidizing agent. Thank you. How about filling balloons? How about filling balloons? 張學良
Helium.
Helium. Yes, that's right. Helium. Helium. What is the atomic number?
Number 2.
Number 2. He period. Group what? Period what? Group what?
Group 0.
group 0, period 1, okay? So we've got electronic arrangement 2 electrons, okay? So it's helium. It is used as a filling balloon. Why? Because has a low density and what? It is chemically inert. We'll call that inert. So what is meant by chemically inert is because we will call it as unreactive. For to compare, in the past, we will talk it as hydrogen, okay? Okay, hydrogen. It is used in the gas in airship. Once in airship, I use hydrogen and make it float. But what will happen at that time is that, you know it? What happened to that time? Why you need to change it? You know it?
Because hydrogen is explosive.
Hydrogen explosive. Can you see that? We've got so many diagrams about that. Now, so the people in the past, they just look for the gas which has a lower density than air, but they have never thought of its chemical property. So it can be easily burned. It can be easily burned, just like a pop sound test, right? A burning split. So whenever there is a spark nearby, so we have got surrounding environment, we have got oxygen, while we have got a whole balloon which contains some gas which is flammable. It's hydrogen. So all in a sudden, we have got a spark, while the whole airship will be burnt. So nowadays, it's not hydrogen. Now, for example, this and this, we use helium, is that because it cannot be burnt. Can you get my point? So remember, you have to choose the correct chemicals based on the different properties. So it's not just density, but also what? Reactivity. We have to think of both. Now we have got 2 modes to go. One is neon science that you may know. The answer is neon. Neon, or advertising science, neon. Hong Kong was once a place where you have got, but isn't somebody asked, but isn't helium flammable too? Okay, the answer is no. Okay, helium cannot be burnt. Why? Now, it belong to noble gas. Now, similar case is on this, and this. These 3 collectively, we call that noble gas. What are they in? It is in group 0. And why is it so stable? It's because we have got completely filled electron shell. What I want to make it clarify in here, in completely filled outermost electron shell, it will give you some extra stability to be gained. Okay, so that's why what is a hidden message? We call it stable. So helium, neon, and also the last one, what is that? Is argon. It's argon. That 3 substances, we call it noble gas. It's very chemically stable. So how we know they're chemically stable? Take a look on that first 2. The first one, neon science. How will you produce the light? How you know? Anyone who know how to produce the light? How to produce light? Anyone who know? Wang Jingtou. Do you know how to produce the light?
No.
No. Just directly tell me no. You cannot. Now, while you are here, you better search it on the web. Tell me how to produce the light using neon. Anyone who can help? You better search on the web now. I will give you some time. And also for argon, same questions applies. I ask you guys to think of how to produce the light is different. For those who know it, you may just turn on the mic and tell.
Because
Could you please introduce yourself? Sorry. Who are you?
I'm 3B27.
Oh, okay. Thank you.
There will be electron go through the wire, and the wire will be heat and light.
Which case? You mean this, the tungsten light bulb? Yeah. Yes, that's right. So it is using the heating effect of that metal. I just tell you what is that metal inside. Inside that, it seems like a coil here, right? So what is that? We call it tungsten. 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 Okay, all of you, could you please mark it down as well onto your notes? Tungsten. TUNGSTEN with a chemical symbol W. So indeed, it is a metal, but it has a very high resistance, unlike copper. Okay, copper is a very good electrical conductor. While you have got a current passing through the electric wire, it produces less heat. But not for tungsten. Tungsten will produce a lot of heat. Why? Because it is a resistor. Okay, have you ever heard of the term resistor? Resistance, right? So whenever we have got something, we have got resistors, when current passing through it, it will produce heat. So high temperature that it starts to glow. Glow, do you still remember that term? Glowing spleen, the same word, glow, which means they shine itself. Okay, glow when conducting electricity. So they will give you some light. Okay. First of all, it seems like a BBQ, right? You may find the charcoal is orange, is yellow, and later on, the high temperature it will give, they will give you yellow or even white light. Can you get my point? So this is how high temperature inside. It will be more than 1,000 degrees. So we cannot just put in air. If air is put in, no way. What will happen? So high temperature that the metal will be corroded. It will be oxidized in air. Okay, so we will use some chemically inert gas. Argon is a choice. Okay, similar case for neon. Neon, how would you produce neon light? Is by having some high voltage passing through the low pressure, the gas of low pressure. So this time I use neon to it. So how high temperature, how high voltage is this? It's about 230 volt, right? I said before, and they will produce some light by itself. And depending on the wrapping paper, if I wrap it is red, it will give you red light. If you wrap it blue, they will give you blue light. So this is what I would like to talk to you about today lecture. Any questions so far? What do you feel about that? But the question comes: how would we get that pure substance in the world? How? I know it's so important, right? How would you make use of these materials as a pure state? Okay, and we will share with you our thoughts next time is about the compound and mixture and pure substances. Okay, is it clear? So it's now 9. I would like to pass the time to the next lesson. Okay, see you guys. Bye-bye.